Look at the skyline of New York or Dubai. What do you see? You probably see progress, but I see a graveyard of glorified caves. Every skyscraper standing today is essentially a dead monument on life support. They are sealed tight, wrapped in glass, and pumped full of artificial air just to stay alive. Think about that. We spend billions on structures that are basically 2 billion coffins. Your own body can regulate its temperature and oxygen without being plugged into a wall. So why can't a massive tower do the same? If nature solved this millions of years ago, why are our greatest cities still holding their breath? To keep people inside from suffocating, we force-feed these boxes through massive metal tubes. We blast them with constant electricity just to keep them from melting. If you pull the plug, the building dies. We've spent centuries building bigger, but we forgot to build smarter. We are still living in Stone Age concepts wrapped in shiny glass. But here's the crazy part. We aren't just building better air conditioners anymore. We're about to witness the birth of a living logic that changes everything. We are moving past the age of the dead monument. What if we stopped building boxes and started growing structures? The first step isn't about steel at all. It's about something much more organic. What happens next will change the very definition of architecture forever. Picture a skyline in the year 2050. It's dusk. The sun is dipping below the horizon, but you don't hear the usual sounds of a city. There is no heavy hum of a million air conditioners. There is no grinding vibration of massive ventilation fans. Instead, there is something else. A low rhythmic pulse. It's deep. It's steady. It sounds almost like a heartbeat. Look closer at the towers. They aren't static blocks of concrete anymore. As the temperature drops, the skin of the building actually moves. Thousands of modular pores across the facade begin to expand. They are stretching. They are catching the cool evening breeze, pulling it deep into the structure's core. This isn't a construction of dead materials. This is an organism. Imagine a skyscraper that wakes up with the sun. Its windows tilt like leaves to maximize energy. Its outer shell tightens during a storm to protect its skeleton. At night it slows down. It enters a state of rest. It manages its own resources with a cold, perfect efficiency. We are talking about architecture with a nervous system, a city that doesn't just occupy space but actively adapts to the environment. In this future, the line between biology and engineering is gone. We aren't just stacking floors. We are designing flow. The buildings don't fight the weather. They use it. They breathe. They sweat. They might even heal. It's a radical shift in logic, a transition from building to being. But to reach this pulsing skyline, we have to solve a massive problem. We have to address the fatal flaw in how we currently create the world around us. Because right now our cities are actually working against us. Right now we are trapped in a cycle of concrete suffocation. We've built a world of sealed boxes and it's backfiring. Here is the staggering truth. We spend nearly 40% of all global energy just fighting the atmosphere inside our buildings. Think about that number. Almost half of our planet's power is wasted because our architecture is constantly at war with nature. We build a glass tower. The sun heats it like an oven, and then we blast massive amounts of electricity into air conditioners to fight that heat. It's a loop of pure inefficiency. It's a mechanical failure on a global scale. But the cost isn't just in dollars or carbon. It's in our own biology. Enter sick building syndrome. Because our skyscrapers don't breathe, the air inside becomes stagnant. It's a cocktail of CO2, synthetic chemicals from carpets, and recycled dust. We've created environments that actually make us tired, unfocused, and physically ill. Our modern offices are effectively high-tech jars with the lids screwed on too tight. We have reached the absolute physical limit of what traditional HVAC systems and glass can do. We can't just keep adding bigger fans or thicker insulation. The old logic is broken. We are trying to solve 21st century problems with 19th century skeletons. If we stay on this path, our cities will become massive, energy-draining heat sinks that eventually collapse under their own maintenance costs. The system is choking. It's rigid, it's brittle, and it's completely disconnected from the natural flow of the world. We need a way out. We need a structure that doesn't just resist the environment, but actually processes it. But how do you make a billion-ton structure move like a living lung? The answer is hidden in a mystery that engineers are only just beginning to unlock. So how do we actually do it? This is where every skeptic stops and asks the big question. How can a massive billion-ton structure breathe without falling apart? If you put holes in a building, it loses its strength. If you add thousands of moving parts, it becomes a maintenance nightmare that breaks in a week. Most people hear living building and they think of plants on balconies. They think of a vertical forest. But that's just a skin graft on a dead body. The real mystery is much deeper. It's happening at the molecular level. Engineers are looking at a biological paradox. Your skin is soft enough to stretch, but tough enough to protect your organs. Your bones are light, but they carry your entire weight. How do we translate that into steel and glass? We are searching for the logic of the fluid. Imagine a material that doesn't need a motor to move. No gears, no oil, no electricity, just a smart substance that reacts to the world around it. When the sun hits it, the molecules tighten and the material curls. When it rains, it expands to drink. But wait, if there are no wires, what is controlling the movement? How does the building know when to open its lungs and when to brace for a storm? We are moving away from traditional construction and into the realm of molecular engineering. It's not about adding more tech, it's about making the material itself the technology. It feels like magic. A solid wall that changes density on command. A structural beam that grows stronger under pressure. It defies everything we were taught about engineering. The secret isn't in a computer chip hidden in the basement. The secret is baked into the very fabric of the walls. But to see how this works, we have to look at a partial answer that's already hidden in nature's most efficient designs. Think of a pine cone. When it's wet, it closes. When it's dry, it opens. It doesn't use a battery. It doesn't have a brain. It's just programmed by its own structure to react to humidity. Now scale that up to a 50-story tower. We are entering the era of the synthetic lung. But let's get one thing straight. This isn't about covering a skyscraper in green ivy. That's just decoration. We are talking about high-tech membranes and smart skins. These are kinetic facades that mimic the behavior of human pores. Instead of traditional insulation, imagine 3D printed biological veins woven directly into the walls. These aren't pipes. They are modular channels that handle airflow with absolute logic. When the air outside is humid, these synthetic veins tighten. When the building needs to sweat to cool down, they dilate. It's a self-regulating system that functions through pure geometry. No complex computers are needed to tell the building to breathe. The material itself is the sensor. It's a design that blurs the line between hardware and biology. We are seeing the first glimpse of a structure that has a metabolism. But how does a bunch of reacting materials actually replace a massive $1 million HVAC system? How do you move enough air to keep thousands of people alive without a single fan? The answer lies in a breakthrough that mimics the most efficient engineers in the animal kingdom. This is the moment where the mystery dissolves into pure high-tech logic. It's called biomimicry, and it is the ultimate reveal of how we kill the HVAC monster. To make a building breathe, we don't need more power, we need better anatomy. At the heart of this organism is the stack effect. It's a simple law of physics: hot air rises. By designing a hollow modular core, essentially a massive spine, the building creates its own internal pressure. As the sun warms the outer skin, the air inside naturally begins to climb. This creates a vacuum at the base, pulling fresh, cool air into the structure through specialized Venturi effect nostrils at the ground level. These aren't just holes in the wall, they are precision-engineered intake valves that accelerate air without using a single fan. As the air enters, it passes through the building's lungs, a series of filtered carbon-scrubbing membranes woven into the structural skeleton. These membranes don't just filter dust, they eat CO2 and breathe out oxygen, scrubbing the air cleaner than the city outside. But here is the real payoff: redundancy. In a traditional skyscraper, if the power grid fails, the building becomes a tomb within hours. It overheats, the air goes stale, and people have to evacuate. But a living skyscraper, it's safer because it's independent. Because its respiration is powered by the sun and gravity, it cannot break. There is no single motor to fail. There is no software to hack. The building's nervous system is decentralized. If one section is damaged, the rest of the modular skin adjusts to compensate. It is a self-sustaining loop of airflow that works 24/7, for free. We are moving from a fragile box that depends on a plug to a resilient organism that thrives on the atmosphere. And the best part? This isn't just a lab experiment. The proof is already being built in the real world. You might think this is all just a dream on a computer screen. You're wondering who is actually going to pay for a building that breathes. The answer is simple: the people who want to save millions. This isn't just a pivot in design, it's a proven engineering revolution that is already happening. Look at the Eastgate Center in Zimbabwe. It doesn't have a conventional air conditioning system. Instead, it's modeled after the logic of a termite mound. By using passive cooling and the thermal mass of the structure, it stays perfectly comfortable while using 90 less energy than a traditional building. That isn't just green, that is a massive financial win. Then there are the Al Bahar Towers in Abu Dhabi. They face some of the most brutal heat on the planet. Their solution: a kinetic solar skin. Thousands of umbrella-like components open and close based on the sun's position. It's a mechanical shield that breathes with the light, reducing solar gain by 50. It's modular, it's adaptive, and it's working right now. Even more radical are the hygroskin prototypes. These structures use the innate properties of wood to react to humidity. No sensors, no motors, just pure material logic. When the air gets damp, the apertures close. When it dries out, they reach open. These aren't just one-off experiments. They are the first cells of a new urban biology. Architects and engineers are realizing that fighting nature is expensive, but mimicking nature is profitable. We've moved past the if and how. We are now in the when. But once these buildings start breathing, they won't just sit there. They will start doing something even more incredible. They will start to heal. Now scale this up. Don't just think about one tower. Think about an entire city, a living metropolis. When we move from individual buildings to a connected urban network, something miraculous happens. We cross the line from being sustainable to being regenerative. In the old world, a building was a parasite. It took energy, it took water, and it breathed out pollution. But in this new biological era, the skyscraper becomes a hero. Imagine a lung building that doesn't just clean the air for the people inside. It's inhaling the smog of the entire neighborhood. Its massive modular skin acts as a giant carbon scrubber for the city. It's eating the toxins from the street level and exhaling pure oxygen-rich air back into the sky. The city stops being a concrete jungle and starts acting like a literal forest. This is the regenerative logic. The more we build, the cleaner the planet gets. Every new structure is a new organ in a global life support system. Instead of fighting for space, these buildings share resources through a subterranean mycelium of pipes and data. They trade excess heat, they share filtered water. They balance the city's metabolism with a cold digital precision. This isn't a fleshy horror story. It is the ultimate wow factor. We are talking about a world where your apartment complex is actually repairing the ozone layer, where your office building is cooling the street temperature by 5 degrees. We aren't just housing humanity, we are curing the atmosphere. We are building a future where the word construction is replaced by cultivation. But as these structures become more alive, a final deeper question remains. If a building can breathe, and if a building can heal, what else can it do? Does it stay the same forever? Or is it ready to evolve into something even more personal? We've reached the limit of what we thought was possible. We've turned dead towers into breathing organisms. But if a building can breathe, and if it can adapt, we have to ask the ultimate question. What is the next great evolution? Because breathing is just the beginning. The real breakthrough happens when respiration turns into metabolism. Think about the logic of the loop. Right now a building breaks down and we throw it away. We call it demolition. But in a living system there is no such thing as waste. Everything is just fuel for the next phase of growth. If a building has a lung, the next step is a stomach. We are looking at the dawn of the self-healing city. Imagine a skyscraper that doesn't just sit there waiting for a repair crew when a crack forms in its skeleton. Instead, it senses the damage. It sends a surge of modular biosynthetic cells to the wound. It eats the carbon from the air, the gray water from the sinks, and even the trash from the bins, and it transforms that waste into raw structural material. It literalizes the concept of growth. We are moving toward a reality where architecture doesn't just age, it matures. Where a city doesn't decay, it evolves. The building of the future won't be built by cranes and hard hats. It will be programmed. It will be fed. It will be raised. But how do you even begin to design a structure that treats a pile of garbage like a gourmet meal? How do we transition from building with steel to building with living trash? That is a mystery of molecular recycling and autonomous growth that most people aren't ready to hear. Because if you think a breathing building is crazy, wait until you see the skyscraper that grows itself from our own filth. What happens when the dump becomes the foundation for the tallest tower on Earth? That's a story for next time. The era of the self-growing city is closer than you think, and the logic behind it is absolutely beautiful. Let's keep moving.